Hello everyone, welcome back to our channel. Today we are going to discuss about valid anagram problem. So here the question is given two strings s and t, return true if t is an anagram of s and false otherwise. So let's understand what is an anagram means. Can we say these two strings are anagram? Yes. Why? Because anagram means both strings must contain the same number of characters and with the same frequency, but the order can differ. In this example, E appeared one time, A appeared one time, T appeared one time. And here T appeared one time, E one time, and A one time. So it has the same characters with the same frequency, but the order is different. That's why it is a valid anagram. Let's understand with the examples. So here in this example one, we have S equals to anagram and T equals to nagram. So in the both the cases, we have the same characters with the same frequency. That's why the output is true. And in the example 2, S is rat and T is car. So clearly we can say T is there in the S but not in the second string. And same as C present in the T but it's not there in the first string S. That's why output is false. Both the strings does not have the same characters. So let's understand the possible approaches to solve this problem. So to solve this problem, first we need to keep in mind that both the strings has to be same size. Let's say we have one string eats and this is with sit. This is not at all a possible for anagram because the number of characters are not same. In this case, there is no possibility for anagram because the string sizes itself is not match. So first rule, we need to check the string sizes. If s dot size is not equals to t dot size, in this case, we need to return false. First, we need to check this rule. So first we need to check the sizes. If the sizes are matched, then only we are going to solve the problem. Yeah, let's discuss about the approaches. So first approach is sorting. In the sorting, we sort both the strings. If sorted versions are equal, we return true or else false. So after sorting, our both strings S and T looks like same. That's why it's a valid. But in our second example, after sorting, so clearly we can say the sorted strings are not same. So it is a invalid. So with sorting is a straightforward approach, but the problem with the time complexity. So time complexity is in this case O of n log n because sorting always creates extra overhead, and space complexities we are not taking any extra memory. That's why O of 1. As time complexity is overhead with the sorting, let's discuss about another efficient approach. So our second approach is frequency counting. In this approach, we count the characters in both the strings and compare the counts. If they match, it's anagram, else false. Here for string S, the frequencies are looks like this. A appeared 3 times and N one time, G one time, R one time, and M one time. And for T, N one time, A 3 times, G one time, R one time, and M one time. So clearly we can say the frequencies got matched. A appeared 3 times in both the strings and N one time, G one time, R one time, and M one time. So we can say it is a valid anagram. And let's apply frequency counting for our second example. Here S, C one time, A one time, R one time, and for T, R one time, A one time, and T one time. So we have frequency count C in S, but it's not there in the T. So we can say invalid because frequency count not matched. So with this approach, the time complexity is O of n, and space complexities, we are using the constant space with 26 characters. That's why space complexity is O of 1. So this is an efficient approach. Let's try to understand the coding part here. This is the frequency array. We try to traverse through the first array. Let's say char CS, increment the frequency array. C minus A plus plus means frequency of C is first time it is A minus ASCII of A. 90 ASCII of A is 97, 97 minus 97, 0. Frequency of 0 plus plus means our 0th index, now it is 1. So let's do this the same thing for all the characters. Next, our character is n. So n minus A, 110. 110 minus our ASCII is 97. 110 minus 97 is 13. So 13th index, we need to increment the value as 1. So let's try to fill the frequency array for all the characters. After that A came, so already our frequency is at a 0th index is 1, now it is 2. Then G came, G's ASCII is 103, so 103 minus 97, 6, 6, and increment. By the end of the first string, the frequency array looks like this. Let's traverse through the second array. This time we are just decrementing our frequency array elements. Same thing, instead of incrementing, this time we are decrementing. Let's say first our n came, so frequency of n's ASCII is 110, 110 minus 97, which is 13 is 13. So we are just decrementing the value. So in the 13 we previously has 1. So after decrementing, the value is here, it is 0. Then we have A. So for A, frequency is 97 minus 97, which is 0. So after decrementing the value, 3 becomes 2. And then we have G. G's ASCII is 103. So 103 minus 97, which is 6. So already we have 1 there. Now we'll decrementing, it is 0. And then A, for A already it is 2. Simply it is 1. After that R's ASCII is 114. So it is 17. 114 minus 97 is 17. And we are decrementing that value, it is 0. And then A, one more time, so 1 becomes 0. And then AM, it is 12 after subtracting with the 97, so value becomes 0. If you closely observe here, all our counts got 0, means we have the same characters with the same frequency. That's why our count in the frequency got 0. So now in the final traversal, we traverse through the frequency array for int count frequency array, let's say, and we will check this the count value. If our count value is not equals to 0, means the strings are not having the same characters with the same frequency. That's why we need to return false. This is the simple rule. So let's apply this rule for our second example quickly. So in our second example, let's traverse through the first string for char C to S and just increment the frequency array. So here our ASCII of C is 99. 99 minus 97, which is 2. So increment the 2 in the index of frequency array. After that A is ASCII is 97, 97 minus 97 0. Let's increase here. And then R's ASCII is 114, 114 minus 97. So which is 17. Let's increment the 17. This is the frequency array after traversing through the S. Then let's traverse through the second string and then decrement the frequency array. So during the second string traversal, our first character is R. R's ASCII is 114. So 114 minus 97. So which is 17. So let's try to decrement this value to 0. And then A. So A is 97. 97 minus 97. So let's decrement the 0. And then T. So T's ASCII is 116. 116 minus 97, which is 19. So let's increment here 1. So let me quickly erase this thing. So after second string traversal, the counter is having 0, 1, 0, 1. So let's traverse through the frequency array. So here our logic is, if count not equals to 0, we need to return false. In this case, we have 1 at 2 and 19, means this is not a valid anagram. It's a invalid. So now let's code for this problem. So here first our rule is, first we need to check both the string sizes. If sizes not match, then we need to return false. So after that we need to take one frequency array which is integer. After that we need to traverse through the first string. So for first string traversal, we need to increment the frequency array. Second string traversal, we need to decrement the frequency array. In the end, we need to traverse through the frequency vector and check if count not equals to 0, need to return false. In the end, we need to return true. Let's run this code. Our solution got accepted. Let's try to submit this one. Yeah, all test cases got passed. I hope you understood the problem clearly. If you have any doubt, please do let me know in the comment section. And please do like and subscribe to our videos. Thanks for watching.